we're going to continue solving systems linear equations, and this time I don't say which method to use. You want to use substitution or you want to use elimination. But to remind you, we've got an ordered pair as one possible answer, no solution, or the equation that describes the line if it's the same. So given the way this problem is set up, this one's equation 1 is already solved for one of the variables. I'm going to use substitution. Now, if that wasn't the case, I would do elimination. So let's write equation 1 and 2. And I'm going to put equation 1 into equation 2 because equation 1's already solved for a variable. Now, what is it solved for? It's solved for y. So I'm going to substitute the 3x plus 3 into the equation number 2 where the y is. And this is what I get. 6x minus 2 times 3x plus 3 equals negative 3. Now let me just check, make sure I wrote it down right. I did. Now I have an equation with one variable. So I solve for the x. I distribute the 2, combine these like terms, and that's 0. Those go away. And I have 6 negative equals negative 3. That is false. So here's your choices. Did you find one of the variables? No, the variables dropped out. Did you get something that could possibly be two parallel lines, or did you get the same line? If you were just taking a guess, what would you guess? False leads to no solution. If this were true, you would get the same line. So a false statement at the end with no variables implies no solution. So let's write that out in words. A false statement implies no solution. You could confirm that those lines are parallel by rewriting them and noticing that the slope is the same, but the y-intercept is different. Okay, you can either write that or you can box in no solution. Either one of those is fine. Okay,